Good morning and welcome to Mission Control Houston and Space Station Live. The team both here on the ground and in space are busy with cargo deliveries and preparations for more deliveries as the Russian Progress 52 arrived this past Saturday and the Japanese H-2 transfer vehicle 4 is scheduled to launch this coming Saturday. Watching over systems here on the ground in the International Space Station Flight Control Room, the Space Station Flight Control team is led by Flight Director Dina Cantella, with Josh Matthew assisting as Capcom. In space, the Expedition 36 crew is more than halfway through their day, which began at 1 a.m. Central Time. They are Russian Commander Pavel Vinogradov, U.S. flight engineers Chris Cassidy and Karen Nyberg, European Space Agency flight engineer Luca Parmitano, and Russian flight engineers Alexander Misurkin and Fyodor Yurchikhin. Cassidy, Vinogradov, and Misurkin launched to the station on March 28th and docked the same day, giving them a tally now of 122 days, both in space and at the space station. Nyberg, Parmitano, and Yurchikhin launched and docked on May 28th, so then they've now spent 61 days at in space and at the space station. Currently orbiting 258 miles above the South Pacific Ocean and heading for the coast of Chile, the Expedition 36 crew has a full agenda planned for the day, with the new Progress 52 having launched from the Baikonur Cosmodrome in Kazakhstan at 3:45 p.m. Central on Saturday. Some video of that launch here. Again, occurred at 3:45 p.m. Central Time on Saturday from the Baikonur Cosmodrome in Kazakhstan. And then the Progress docked then to the Pirs docking compartment at 9:26 p.m. Central Time that night. Following that launch and docking, Russian crew members were able to get the hatches between the two vehicles open on Sunday and have now begun working hard to begin unpacking the almost 3 tons of food, fuel, supplies, and experiment hardware that it delivered. Included in that was some tools and spare parts needed to troubleshoot the spacesuit that gave Luca Parmitano trouble during his spacewalk with Chris Cassidy on July 16th. Team members here on the ground are still working through their analysis of the root cause of the water leak that caused the water to begin building up in Parmitano's spacesuit. A second round of troubleshooting was completed with the crew on Friday, and the team is now assessing the results and next steps for the troubleshooting this week. Meanwhile, the flight control team in Europe is working through a problem with the data processing units on the Albert Einstein Automated Transfer Vehicle 4, docked to the end of the Zvezda service module. The vehicle has 3 data processing units, and one was isolated from the rest of the system after a telemetry issue was detected early last week. Then on Sunday, another data processing unit developed a similar problem and was also isolated. The ATV can function on just one data processing unit, however, a second is needed for it to stay at the space station for redundancy. So engineers here on the ground are working to reset the computers and get them reintegrated into the larger system. In the midst of this, the crew is also getting ready for a third visiting vehicle, Japan's Kanotori H-2 transfer vehicle number 4. It's going to launch from the Tanegashima Space Center in Japan at 2:48 p.m. Central Time on Saturday and berth the morning of August 9th. It will be brought in for the berthing by the space station's robotic arm, driven by Karen Nyberg and Chris Cassidy with help from Luca Parmitano, and they're brushing up on their skills for that activity today, with some time at the robotic workstation inside of the cupola. On top of all that, all 6 members of the crew are involved in a variety of experiments looking at astronauts' diet, reaction time, and vision on orbit, as well as liquid transportation and microgravity, dynamic loads on the space station's joints, and biomass production using a bioreactor. That's what's going on in space today, and this is Mission Control Houston. Next big event, as I mentioned, on the space station horizon is the launch of the fourth Kunitori H2 transfer vehicle from the Tanegashima Space Center in Japan on Saturday. And you can see the crew here getting ready for it as we speak inside the space station's cupola, the bay window basically, inside the station's Node 3. That launch is scheduled to take place at 2:48 p.m. Central Time, and you'll be able to watch it here on NASA TV with coverage beginning at 2 p.m. The HTV is going to be carrying to the station experiment samples and equipment including Frost, the freezing refrigerator of Stirling cycle, which is able to maintain a negative 70°C temperature and stay cool even without power. And Icebox, the ISS Cryogenic Experiment Storage Box, it's also able to maintain a cool temperature for transfer of experiment samples without power. The HTV will also be carrying another eyeball experiment, just as the previous HTV did. That is a reentry data recorder that will relay information on the HTV's return to Earth and its burn up in the Earth's atmosphere when its stay in space is over. And there's also supplies, food, water, and clothing for the crew aboard the HTV-4. However, the HTV-4 won't actually make it to the station until August 9th, when it's scheduled to be brought in for a berthing to the station's Harmony node at 6:29 a.m. Central Time. And although most of the other vehicles that visit the space station dock automatically,
Station Houston on Space.
The HTV is captured using the space station's robotic arm, which is driven by the crew to the Harmony node.
Yeah.
The crew has been spending a good deal of time today brushing up on their robotics training to ensure that they'll be ready for that task when the time comes. You can see Nyberg and Cassidy here again inside the cupola on the station's Tranquility node, practicing at the robotic workstation that's set up there. It offers an especially good view of the space station's exterior with its bay windows, and they're using that view to brush up on their skills with the space station's robotic arm in preparation for using that to grab onto the HTV-4 and bring it in for its berthing. Besides this actual training that they're doing now, they also had a conference with the trainers on the ground before they started it and spent some time reviewing the system's protocols before they actually started the training. And once they finish, they'll have a debrief on the training and how it went as well. There's a view here outside the space station looking at the end effector on the robotic arm, basically the hand that allows the arm to grab onto things. They are practicing actually grabbing onto the grapple fixture that you can see here in the center of the screen, maneuvering the arm up to it, and then basically pulling the trigger that will allow it to grab onto the grapple fixture. One of the main purposes of the training session today is to give the crew time to think about how they are going to want the robotic workstation set up on capture day. Make sure everything is at easy reach inside the cupola, and they'll have what they need, including the video views that they'll want to ensure that they have the best view of the procedure as they are working through it. Part of that is lighting on the grapple fixture and how it changes as the position of the sun changes throughout the operations. They'll also want to make sure that they know of any points where the lighting is too poor to proceed with the grapple as well. They do a great deal of training for these activities before they ever leave the Earth, but having been in space for some time now, since May for Karen and March for Cassidy, it's always good to brush up before the skills are actually put to the test in space. Although you can see Nyberg here talking with the microphone, the reason we're not hearing her is because she's likely talking with Luca Parmitano, who is going to be providing some situational awareness from other views on the space station. That's another thing that the crew is practicing today. Working out the communications between the cupola and the robotic workstation inside the Destiny laboratory as well. As I mentioned earlier, ground controllers with the European Space Agency are currently working to reset some of the computers on the Albert Einstein Automated Transfer Vehicle 4, which has been docked to the Russian Zvezda service module since June 15th. Two of the station's 3 data processing units have experienced telemetry issues that cause the system's fault detection system to isolate them. That doesn't affect the station operations at all. The ATV can run on 1 data processing unit without a problem, but flight rules do require that the vehicle have at least 2 operating units for fault tolerance. Otherwise, it could be required to undock from the station early. Engineers on the ground are trying to avoid that by troubleshooting this issue today and, if needed, tomorrow morning as well. The first issue occurred last week when data processing unit number 2 experienced a telemetry issue and was isolated from the rest of the system. Then yesterday, data processing unit number 3 also failed. The ATV Control Center performed data dumps and analysis and decided that the data processing unit 3 failure was of a transient nature, and they made plans then to reintegrate it back into the system today. They've been working to reset the computer and get it reintegrated this morning. That process takes about 3 hours, and they expect to know the results this afternoon. If it's not successful, they'll try again tomorrow morning. And once they do get the data processing units back up and running, they'll also want to verify the thrusters are healthy on the ATV with some small firings to test it. Again, that troubleshooting is going on as we speak from the ground controllers with the European Space Agency, and we'll be ready to report the results of it to you tomorrow morning. Among the supplies delivered by the Progress 52 Russian transfer vehicle on Saturday was some tools and spare parts needed for the ongoing troubleshooting of the spacesuit that Luca Parmitano wore on his and Chris Cassidy's July 16th spacewalk. That spacewalk was ended after just an hour and a half due to a water leak in Parmitano's spacesuit. Engineers here on the ground have been looking at what caused the water to build up in his spacesuit since then, and in fact, a second round of troubleshooting was completed with the crew on Friday. The team here on the ground will now be assessing the results of that troubleshooting session and looking at what steps to take next this week. They've actually isolated the failure to the spacesuit's primary life support system, which is essentially the backpack of the suit. And there are 4 potential suspect components in that system: the sublimator, the gas trap, the condensate water relief valve, and the water separator. On Friday, the crew inspected the MEDOX input-output and vent ports for damage and/or water and found that it all looked normal, as did the condensate water relief valve, the water separator, and the cross loop. The troubleshooting on Friday didn't include the gas trap, however, so that's going to be something that the team will continue to consider as they move forward in their analysis of the troubleshooting and think about what steps they'll want to take next.
Moscow station SG1. Go ahead.
Alexei, process activation is
Alexei, activation is completed and the hardware is installed in the freezer per 2915 at 15:18:35.
15:18:35 принято.
15:18:35, copy.
Ну, а также хотел
Also, I wanted to mention that
будет папочка по номеру радиограммы.
there will be a TV greeting folder in OCA with the radiogram number for the name. And also, there is another folder in OCA. There will be pretty soon for mine and further activities. And again, the name matches the radiogram number. Okay, copy.
In addition to all the work that the crew is doing today to begin unpacking from vehicles that arrived and preparing for vehicles scheduled to arrive, they're also doing quite a number of science experiments as well, including some work here at the Microgravity Science Glove Box that you can see Chris Cassidy working with today. One of the things he'll be doing there is working with the capillary channel flow experiment. That is a study that aimed at helping to innovate solutions to transporting liquids like fuel, low temperature liquids like liquid nitrogen, and also water in microgravity. The idea is that understanding capillary fluid flow rates in microgravity can help us develop hardware for pumping liquids from one reservoir to another without the need for a pump with moving parts. The reduced cost, weight, and improved reliability of such equipment would make this a particularly attractive technology for NASA to use. At the moment, spacecraft fuel tanks rely on an additional reservoir to prevent the ingestion of gas into engines during firing. So being able to get around that would save weight and make the hardware simpler, which is always preferable when you can do so. Cassidy has actually been working to take down the hardware used for the capillary channel flow experiment now that it has completed its experiment run. And again, that takes place at the Microgravity Science Glove Box, which you saw him working on just then. We have now a short feature to tell you a little bit more about what the Microgravity Science Glove Box is and what it's used for, coming up next here on NASA TV. This is Mission Control Houston.
The Microgravity Science Glove Box, located in the Destiny Laboratory, provides 9 cubic feet of enclosed workspace for conducting a wide variety of experiments that require liquids, combustion, or hazardous materials. ISS crew members can safely use its rugged gloves to work in a sealed environment without the risk of releasing any small parts, particles, fluids, or gases into the rest of the laboratory. The Structure and Liftoff in Combustion Experiment, or SLICE, utilizes the MSG to study and work with fire in microgravity. SLICE allows astronauts to photograph and measure the shape and temperature of flames produced by various fuels and sizes of burner nozzles. These assorted flame shapes and sizes are then modeled to help scientists develop more efficient engines and furnaces here on Earth. The MSG is also used to conduct the BASS experiment, which stands for Burning and Suppression of Solids. Instead of measuring flames from burner nozzles, the BASS experiment observes and models the geometry of flames on solid spheres and flat surfaces. These controlled fires are then extinguished in a variety of ways to look for the best strategy to use for suppressing flames in microgravity. Improved fire detection and suppression systems for use on Earth and the ISS can then be designed from this information. The MSG is also used to accommodate tests for heating liquids in the boiling experiment facility, a small container that includes 2 types of heating arrays, high-speed video cameras, and a variety of tools for measurement. Experiments in the BXF try to determine critical heat flux, the point at which a heat source becomes so hot that the liquid can't actually touch it. Interestingly, the information from the study of critical heat flux is used to design enhanced cooling systems. The VXF's heating arrays are also used to study the shape and buoyancy of bubbles. The high-speed cameras in the VXF capture the growth, detachment, and motion of two types of vapor bubbles, small individual bubbles and larger bubbles that have merged together. Without the microgravity science glove box aboard the ISS, there wouldn't be a safe way to work with dangerous materials and conditions to carry out these compelling experiments.
That again was a look at the microgravity science glove box and the many uses that it has in orbit. Again, Flight Engineer Chris Cassidy was doing some work with it to take down the equipment from the capillary channel flow experiment, now that that experiment has been completed for the time being. Another experiment that some of the crew members are taking part in today is the ocular health experiment. It's a prospective observational study of ocular health in space station crews. And flight engineers Karen Nyberg and Luca Parmitano are both taking part in those tests today. The study is aimed at characterizing the risk and defining the visual and central nervous system changes that are observed during a 6-month stay in microgravity, including post-flight time once the crew members have returned to space, to Earth. The idea is that by systematically measuring visual, vascular, and central nervous system changes over the course of the experiment, the information could be used to build a database that could inform future in-flight research protocols, identify mechanisms, develop countermeasures, and direct clinical monitoring and practice guidelines. There's a possibility that conditions in microgravity are wholly or partially responsible for some degeneration in vision that's been noticed in some astronauts, and future exploration missions could be vulnerable to that as they're 5 times longer in duration than current space station stays. So it's important that the flight surgeons here on the ground have a good understanding of exactly what happens and are able to come up with some activities to counter any degeneration and deal with it as it occurs on long stays in space. Part of the study includes regular vision assessments on orbit, and Nyberg and Parmitano are both taking part in that today, doing just a basic eye exam, much like what we do here on Earth with an eye chart, and checking out how their vision is performing in space. And they're also measuring the pressure in their eye using an intraocular pressure measurement, another part of the regular tests that the crew members are taking part in during their stays in space as part of this experiment. One of the activities on board the space station that go on basically without much work needed by the crew other than setting it up is the work that goes on inside the combustion integrated facility, where a number of experiments are performed on different aspects of combustion that are of interest in space. And we have next for you here on NASA TV a short feature on that experiment facility. This is Mission Control Houston.
The Combustion Integrated Rack, or CIR, in the Destiny Laboratory makes it possible to perform a wide variety of experiments that teach us how fire behaves in microgravity. In the center of the CIR is a large round chamber called the Multi-User Droplet Combustion Apparatus. This 100-liter chamber has 8 windows and 5 cameras that allow scientists to observe patterns made when burning fuels under different conditions. The 5 cameras are capable of photographing high-resolution, high-frame-rate images in ultraviolet low light and in multiple spectrums that are specific to combustion events. Several additional hardware components can be added to the CIR to customize its chamber for specific experiments. FLEX is the flame extinguishment experiment that utilizes the CIR to conduct various burn tests on gas and liquid fuel. It also tests the effectiveness of different methods for extinguishing the flames from the test. ISS provides a sustained microgravity environment, which allows scientists to observe the geometric, chemical, and thermodynamic properties of both the flame and the fuel droplet inside the burn chamber. Under these conditions, we can advance our fundamental understanding of how fuels burn in microgravity, as well as on Earth. This research will be used to better address fire hazards associated with liquid combustibles. The wealth of information obtained from the test in FLEX will also help scientists on Earth solve problems with pollution that is generated by combustion. The many different experiments in the Combustion Integrated Rack will help engineers increase the efficiency of gasoline and diesel engines here on Earth, and will also help us understand fire prevention and suppression.
That again was a look at the Combustion Integrated Rack, which is also being put to use today by scientists on the ground with a little help from crew members on board the space station. Another experiment that flight engineers Karen Nyberg and Luca Parmitano are working on today is the reaction self-test. That's a psychometer vigilance self-test on the International Space Station. And it is basically a portable 5-minute reaction time task that allows crew members to monitor the daily effects of fatigue on their performance while on board the space station. The idea is to give crew members a way to objectively identify when their performance capability is degraded by various fatigue-related conditions that can occur in the day-to-day operations of the space station over their time in space. It evaluates the extent to which their performance is sensitive to fatigue from sleep loss and circadian rhythms disruption. Circadian rhythms are biological functions occurring in a 24-hour cycle, such as sleeping and eating. It also looks at how things like fatigue from work intensity during the mission and decline in performance over time during the mission, and any carryover effects of medications for sleep that might be used. Crew members will be performing this test at the end of their day, just before they begin their sleep period, as a way to evaluate how the day's activities have affected their performance. Flight engineer Luca Parmitano is also taking part in the Pro-K experiment, which looks at dietary intake and how it can predict and protect against changes in bone metabolism during spaceflight and recovery. Just as the name indicates, the Pro-K experiment proposes that a flight diet with a decreased ratio of animal protein to potassium will lead to a decreased loss of bone mineral. Bone health is one factor that is of particular interest to scientists here on the ground, looking at how to keep astronauts healthy in space. For various reasons, astronauts tend to experience some bone loss while they're in space, and so a number of different counter activities to help with that are being looked at, and this particular experiment looks at how the diet that astronauts take part in while they're in space might be used to decrease the loss of bone mineral that's seen during flight. The specific hypothesis is that the ratio of acid or animal protein to base or potassium in the diet can be correlated to bone metabolism and bone loss after spaceflight. Ideally, Pro-K could result in dietary countermeasures for bone loss that could be used by crew members during future space flights. And to work out what those might be, the test calls for astronauts who are taking part in it to go through 4-day periods where their diet is specifically controlled. And then also do the same for 3 post-flight sessions. To tell you a little bit more about bone loss in space, we have another short feature that we're going to play here for you next on NASA TV. This is Mission Control Houston.
Hi everybody, Josh Byerly with NASA Public Affairs. We are directly across the street from Rice Stadium. That is the site where in 1962 President John Kennedy gave his famous moon speech, which set America on a course of exploration. Today, we're here to celebrate the grand opening of a brand new facility which is in partnership with NASA, the National Space Biomedical Research Institute, and Baylor College of Medicine. And what this facility is doing is bringing together scientists from all over to take a look at how the human body reacts to being in space. Some of these experiments are truly out of this world.
So I was an intern in the Space Life Sciences branch for a couple of summers ago here at NASA JSC, working with the bone discipline lead, Dr. Jean Sabanga at NASA JSC, working on, actually I started work, was working on osteocyte bone cells, and that research eventually got turned into a national lab experiment that we're prepping for the International Space Station.
So talk a bit about the whole process of the national lab. Like, you guys you're basically just doing an experiment now, but you're putting it through the review cycle, and then eventually it'll fly, right?
Correct. So the national lab, it went through a joint review session by NIH to select the science, and then NASA is supporting the launch and the logistics to get cells up to station, helping run the experiment on station, and then the cells will come down to the ground for post-experiment analysis. So we're developing, we're flying hardware that was originally flown by the Canadian Space Agency. It's called eOsteo, and it was flown on a couple shuttle flights. And then the Canadians and NASA have worked out agreements to have this hardware retrofitted to be able to fly on the International Space Station, which is great because it's showing the international partnerships between the space agencies and allowing U.S. investigators like ourselves to be able to use the hardware. So
this is former shuttle hardware that you guys are going to basically refit so it flies up to station once more.
Correct.
Different type of experiment or what?
It's a different type of experiment. We're flying different types of bone cells. So in the past, osteoclasts and osteoblasts, so different types of bone cells, have flown in this hardware, and then now we're retrofitting it to fly the third type of bone cells that have never actually flown in space before, osteocytes. They're
like, where are they from? What kind of bone cells?
So they're actually the most abundant cell in bone. They're the most terminally differentiated cell type in bone. Unfortunately, we actually know very little about them because they're very hard to isolate. They come from the mineral matrix in the bone, and so until recently, we've had trouble as a science community studying these cells. However, they're thought to be the cells in bone that respond to mechanical forces and sense gravity. So it's very important that we fly these cells on ISS and try to understand their biology and microgravity.
Talk about bone loss. I mean, it's a big deal. You know, we've noticed that the astronauts lose quite a bit of muscle, quite a bit of bone loss. Talk kind of your thoughts on that, you know, where you kind of hope to see the science go.
So I mean, bone and muscle loss have been a hallmark of spaceflight for the last 50 years. And we're trying to figure out, or NASA's trying to figure out, countermeasures for preventing bone loss. It's one of the main risks to long-duration spaceflight, going to Mars, going to deep space. And so we're kind of attacking it from a pharmacologic agent. NASA has other, and NSBRI has other countermeasures, attacking it from exercise countermeasures. And so I kind of see it going eventually. The solution is going to be pharmacologic plus exercise as a solution to preventing muscle and bone loss in the future. So
how cool is it to actually be working on something you're going to see actually fly up into space here in probably just a couple of years?
Yeah, it's really cool. Like working on SDSS 2035 was an amazing experience, and then working on the cell line work that I'm working on now. So everything is myself and a couple other small team of graduate students are working on this project. So it's pretty amazing that we're going to get to fly this experiment up to ISS and get to use the International Space Station National Lab component. So.
That again was a little bit more information on bone loss and what we see in space and how we're working to counteract it. And again, one of the ways we are working on that is the Pro-K experiment, which Luca Parmitano is participating in today. And in addition to the benefits it could have for spaceflight and future astronauts, it could also be helpful for those of us here on Earth, as well, as there's a growing trend in the United States towards diets high in animal protein. And since this study looks in particular at whether or not the decreasing the ratio of animal protein to potassium in a diet can help in decrease the loss of bone mineral, that could be useful for public health in the U.S. as well. An update now on the ATV troubleshooting that's been going on over the course of the hour that I mentioned earlier on, as we talked about two of the three data processing units on the ATV-4 that's currently docked to the Zvezda service module. Had shut down last week for one of them, and then yesterday for a second one, and so the teams in the European Space Agency had been working on resetting the computer for the ATV and bringing those data processing units back into the system. And they've now confirmed that they were able to get both of the two that had failed recovered and are now back in sync with the one that had continued running. And so the ATV is back in its normal configuration. They are still working, however, to determine what the root cause of those problems was. So there's still some work to be done, but everything looking like it's getting back to normal now on the automated transfer vehicle, or ATV4. We talked earlier about how the Expedition 36 crew members got a delivery of spacesuit tools along with some food, fuel, and supplies on Saturday in the Russian Progress 52 transfer vehicle. That launched from the Baikonur Cosmodrome in Kazakhstan at 3:45 p.m. Central Time on Saturday, and followed the recent trend of the same-day launch and dockings to arrive at the space station's Pirs docking compartment that night. This is some video from that launch. Again, occurred at 3:45 p.m. Central Time from the Baikonur Cosmodrome in Kazakhstan. It carried with it a total of almost 3 tons of supplies, including 1,212 pounds of propellant, 42 pounds of oxygen, 62 pounds of air, 926 pounds of water, and 3,305 pounds of spare parts. You can see it here coming in for its docking at the Pirs docking compartment on the Russian side of the space station. The Pirs had been vacated on Thursday by the Progress 50 vehicle after its 5-month stay had ended. That came with a push by the crew to fill the Progress 50 vehicle up with trash to burn up in the atmosphere, and now they're busy again getting the new vehicle unloaded. That's one of the primary activities that's going on the Russian side of the space station today, but there are several science experiments going on there as well. And among the experiments they're working on are the bioemulsia experiment, the identification experiment, and the conjunction experiment. The bioemulsia experiment uses a thermally controlled bioreactor to produce a biomass of microorganisms. The idea is to develop a moderate stage technology to produce biomass and biologically active substances and provide a highly efficient, ecologically safe production of bacterial, fermental, and medicinal preparations. The identification experiment looks at identifying some of the dynamic loads on the space station's Russian segment that are imparted to its joints when different dynamic operations are performed at the space station, such as docking, reboost, physical exercise using the station's treadmill or exercise bike or weightlifting equipment, as well as spacewalks. idea is to determine the microacceleration conditions in areas of technological experiments that affect the way that the space station ages over time. And the conjunction experiment studies the exchange of genetic material in microgravity in hopes of developing strains that can produce new target proteins. They hope to eventually be able to select optimal conditions for genetic material transfer during bacterial conjunction and protoplast fusion under orbital flight conditions as part of that experiment. One other activity that's going on the space station today, without much work needed from the crew, is the SCAN experiment. That's a space communications and navigation test bed that allows different radio vendors to provide software to a radio platform and demonstrate multiple radio implementations of the Common Architecture Standard. Each radio within the experiment demonstrates the operation and reconfiguration among different signals, such as communications with relay satellites and current and future GPS signals. And then that's used to assess the performance and procedures for Ka-band antenna tracking and performance. That again is an example of one of the many science experiments that go on board the space station that don't actually require much crew time at all, but still are able to take advantage of the orbiting laboratory that the space station provides. We're coming up now on the end of today's Space Station Live. Coming up next on NASA TV, you'll get a look at some of the other activities going on at NASA centers around the country in the NASA TV video file. That begins at 11 a.m. Central Time, and then we'll be back tomorrow at 10 a.m. for tomorrow's Space Station Live. This is Mission Control Houston.